Good morning, afternoon, or evening, depending on when y'all watching this. First video for Algebra 1. Yay! Exciting. I am. Hopefully you are. And hopefully you can gain something from here and learn something or understand the concept that I'm starting with. Today we are starting with expressions. Man, I don't know if you guys can hear this, but it is raining and windy outside. It's raining like crazy. Yeah, but it's raining a lot, and it's very windy. So, what other fun way to keep yourself dry and warm, but besides math? I don't know. Maybe. No? Okay. It's all right. Expressions. Now, Algebra on one of the most, or probably the most, one of the most important concepts is, or things that we learn are variables. I mean, they're just everywhere. I mean, you start from here and they're included in everything that we do moving forward. Now, what is a variable, you ask? Well, a variable is just some sort of symbol or something. In this case, we'll be using letters. As you move forward, Algebra 1, Geometry, Algebra 2, Pre-Calc, Trig, Calculus, whatever it is, however far you go in terms of mathematics, you'll be dealing with letters most of the time. So, a variable is a letter that represents a number. Could be a symbol sometimes, if they feel like it. I don't know how if they want to be wild or go wild one day, you want to use a symbol, A, go for it. In this case, no, that is some sort of symbol or letter that represents a number. So we'll just write that variable. It's nice to write stuff down. Keeps it, or helps, I guess, a little bit. I don't know. Variable, symbol, A. Handwriting is beautiful. Don't say anything. Or letter that represents a number. Represents, a number. Yay. So, good. We got that down. Now, like for example, AX, example, X, Y. Sometimes you might see a triangle or a square or I don't know. They might go wild with the symbols, It might be a question mark sometimes. It might be exclamation. Well, no, not exclamation mark means something else. So I don't believe they'll use it. I don't know. It could be anything, but mainly it'll be a letter or some sort of something. Okay. Just put one more thing down. Rectangle. See, that's how, just no creativity right here. I'm sorry, guys. This is the best I could come up with. Variable, boom, got it down. Hopefully you understand it. We'll move forward. Now, an expression, another important concept, an expression versus a equation, right? Now, an expression is some sort of mathematical phrase, basically, that includes, so we'll write it down, math phrase. You want to write mathematical, go for it. Math phrase that includes is a word that I'm looking for. That has, I don't know. You know what? We'll use has. Could use include, I guess. That has a, I don't know, that consists. I like that word. There we go. You get a lot of this, guys. It's okay. That consists of a, I don't know, number, sometimes variable. That's where you get algebraic expression from. Variable, and of course, some sort of, we'll say, operator. It's an operator. You know what an operator. Hopefully that's how we spell it. Operate, like an operation, like multiplication, division, subtraction, addition. So an operator is for an addition sign, a plus sign. Hold on, I got you. Don't worry. Plus, minus, multiplication, division, some type of sign. Okay. So for example, m plus 6. That's an expression, and there's no equal sign. So that's the difference between an expression and an equation. An equation will be m plus 6 equals 10. Now you have an equation. In this case, you also have more specifically an algebraic equation. M plus 6 an expression, and again, more specifically an algebraic expression. So the only difference here between a or between the general expression and an algebraic expression is that an algebraic expression has a variable, includes a variable or more than one variable. Okay, so more than one variable will look like this: x plus y. There you go. Even 2 plus 6, that's an expression, right? It's not an algebraic expression because there's no variable, but it is an expression. I don't know. N minus 6. I told you, no creativity. It's all addition. I don't know what's up with me today. M divided by 9. Another way you can write m divided by 9, guys, and you'll see this a lot, is like this. It looks like a fraction because fraction is also division. And don't worry, bear with me. I know you guys don't like fraction, but bear with me. We won't get right into it right away. I'll ease you right into it. But that's another way you can show division, m over 9. And then multiplication, 2x. Now, as you move forward, you'll learn that with multiplication, we don't write the multiplication sign. It's usually just a number right next to a variable. You know what? X was probably a bad example because you probably thought I meant 2 times. Or maybe you didn't. You got some bright ones watching this. 2m or 5n. Okay? That means 5 times n. 2m, 2 times m. All right? Hopefully, you've understood this whole concept so far. So, expression is a math phrase that consists of a number, could have a variable, and an operator. When it does have a variable, it is an algebraic expression. I don't want to write any more definitions than I have to, but just know that algebraic expression includes a variable. So, you know what? I'll write it down and not have doubts later on or regrets. Algebraic, did I write numbers? Oh my God. Algebraic, what am I doing? Expression. Okay, algebraic expression, it includes at least one variable. So an expression that includes, see now I come up with includes. Before I could barely come up with consists. I don't know what is up with me today. That includes at least, it could have more than one, but at least one variable. Guys, if you feel like I'm speaking fast or I'm going too fast, please leave something in the comment, and I'll, for future videos, of course, try to tone it down a little bit. I don't know, I just get a little too excited, I guess, when teaching this stuff. So, that's what we have so far. Now let's move into evaluating expression. Now what we mean by the word evaluate, and that's another important thing that you'll see a lot. You'll be surprised how many times I get asked that question. Mr. Z, what does evaluate mean? What is evaluate? What does evaluate mean? Evaluate, what is that? Guys, evaluate just means solve, okay? Evaluate just means solve. So anytime you see the word evaluate an expression or evaluate this equation, that means solve it. Okay? So evaluate, so when we evaluate an algebraic expression, all we're doing is substituting and the number that they give us for each variable that also they give us. Okay? So I'll show you what I mean by showing you some examples. Evaluate the expression when n equals 3. So 13n. That's number 1. Number 2, 27 over n. Number 3, n minus 2. Number 4. Why did I make number 4 different than all of them? Sorry, 4. You won't be left behind. Ouch, my ear. I don't know. Sorry. 10 plus n. Okay, so remember, let's do number 1. 13n. Remember how I told you whenever you see a number right next to a letter, there is nothing in between here, right? No operation. There's no addition sign, no subtraction, no multiplication. It means multiplication. Anytime you see a number right next to a variable and there's no any type of operator in between, operator, that word seems weird. Any type of sign in between, then you know it means multiplication. So 13 times n. But instead of n, they told us that n equals what, guys? It equals 3. So this means 13 times 3. The way I'm writing it just means, again, so I guess another thing you learned here, hopefully, anytime you see parentheses next to, or a number right next to a parentheses, it also means multiplication. So this is the same as saying 13 times n, or sorry, 13 times 3. Again, that little dot also means multiplication. Man, y'all learning a lot for a first day. Hopefully you've known all of this. If not, hey, that is all right as well. Now you know. So 13.3, that means 13 times n. So 13 times 3, that's 39. Wow, that definitely took a lot longer than it should for solving this question. 27 over n, remember how I told you division can be shown like this? So this just means 27 divided by n, which is 3. So 27 divided by 3, that is 9. N minus 2, instead of n, again, we're just going to substitute 3 for every n that we see. So for this n, right here, we're just going to replace it with 3. So 3 minus 2, that's 1. 10 plus n, that means 10. And again, for n, we're just going to substitute it with 3. So 10 plus 3, 13. Yay! At the end of this video, I'll list a bunch of problems that you guys can do. Maybe like leave the problems on for like 10 seconds, and then after that, I'll put the answers. So just pause it, solve them, and then you can check your work at the end. I feel like hopefully that will be helpful for you guys. If not, guys, I know I'm going to be moving up and down. If you feel like you haven't written everything down, just pause the video, write everything that you need, and then continue. All right, now so again, we're still talking about expression, but let's just pause for a moment in expression and just introduce either something. It could be a new concept for you, but hopefully, again, if it is, 100% perfectly fine. If it's not, if something that you already know, just bear with me a little bit. So what I'm going to introduce right now is exponents. If you don't know what exponents are, think of exponent as just repeated multiplication, right? Well, technically the word is, I think the mathematical word is power. That's what a repeated multiplication is. An exponent is just the number, and I'll show you what that is. So for example, 4 to the power of 3, okay? This whole thing, let's use a different. This whole thing right here is called the power, right? And that just means repeated multiplication, okay? Like, do you remember how when you guys were first introduced into multiplication, you were told that that's repeated addition? And maybe when you were introduced into division, you were told that's repeated subtraction. Well, power or exponents, we are talking about repeated multiplication. Okay? Now, for each power, we have 2 numbers, and those 2 numbers are very important to understand what each one represents. First, you have the bigger of the 2. When I mean bigger, I don't mean it could be 3 to the power of 4. Well, I just mean the way it's written. It's a larger font usually. Is the base. So this number right here, not the exponent itself. This number right here, in this case it's 4. This is called your base. And then this number, this tiny number is up here, is called your exponent. So just to know the difference between your base and your exponent. Now, repeated multiplication means you take your base, and that's the number you're going to repeat. That's the number you're going to multiply to itself. And the exponent is how many times you're going to multiply that number by itself. So 4, we're going to multiply it to itself 3 times, because 4 to the power of 3, or just something that you guys should know. Anytime you see 3 as the exponent, that's called cubed. So you hear that word a lot, 4 cubed, 3 cubed. That just means that number is being that just means to the 3rd power. So 4 times 4 is 16. 16 times 4 is 64. All right? Great. Again, I'll do some more examples just so you get in the habit of this and you understand. Hopefully you are a little bit more comfortable, and then we'll see. Let's just start 3 to the power of 4. We'll do that for number 1. Number 2, we'll do 8 to the power of 1. Number 3, we'll do 1/3 to the power of 4. Why not? And then number 5, Bear with me. I know you see a fraction and you're worried. Don't worry about it. It's fine. Excuse me. Y to the power of 6. Oh, we already did 4. You know what? Let's change it to the power of 1/3 to the power of, I don't know, 2, I guess. I wanted to do a bigger number. You know what? Let's do a 3. Why not? All right, 3 to the power of 4. Again, you're going to take that base of yours right here. Different color right here. 3. And you're going to multiply it to itself 4 times. 3 times 3 times 3 times 3. See that? I have 4 3's and I'm multiplying them to themselves. To themselves? Itself? Yeah. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. Again, if you want to pause and do it yourself, go for it. 8 to the power of 1 is just 8. Anything to the power of 1 is just that number. Okay? 1/3 to the power of 3, that just means 1/3 times 1/3 times 1/3. 1, again, when you multiply fractions, you just multiply all the top numbers by themselves and all the bottom. So 1 times 1 times 1, 1. The bottom numbers now. 3 times 3 is 9. 9 times 3 is 27. And then y to the power of 6 is just y times, ooh, that did not look nice. Y times y times y times y times y times y. Why are you doing this? Why? Let's move forward. Oh, one more. I just wanted to show you this one because this one's actually important. And some teachers try to trick you, by putting this one. But know that, whoa, I just caught myself. I just did. I know what I did. I'm sorry. See, I did 1, 2, 3, and then for some reason wrote 5 for number 4. Man, 4 today is just getting it from me. I am sorry, man. Number 5. So the one thing that I wanted to, anytime you see that, you have a 0 as an exponent. So 11 to the power of 0, anytime you have a 0 as an exponent, your answer will be 1. Okay? So anytime you see a 0 as an exponent, just know that your answer will be 1. Woohoo! Yay! So anything to the power of 0, 100 to the power of 0, 1. 3 to the power of 0, 1. 20 to the power of 0, uno, 1. Yes, that's the way it's going to be. All right, let's move forward. So I just want to introduce exponents before I do anything. All right. Now, let's evaluate expressions again, but this time let's use exponents when we do so. So we'll go back to evaluate the expression. And again, remember, evaluate just means solve. Hopefully, some of you or you guys were like, yo, I know what that means now. Don't need to ask anymore what evaluate means, because we know. Yes, we do. Let's do n to the power of 2. Let's do, for 3, we'll do, you know what? I like y. Y to the power of 5. So x to the power of 4, don't worry, I'll tell you what x is. When x is 2. When n is 9. When y equals 1. Is Mr. Z trying to trick us? I think not. X to the power of 4 when x, remember, all you're doing is substituting or replacing the x with 2. So for this x to the 4th, it's going to be 2 to the 4th. So 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Yes. N squared. Remember, n is 9. So we're just replacing n with 9. So instead of n squared, we have 9 squared, which is 9 times 9, which again is 81. Y to the 5th power. All that means is y times y times y times y times y times y. But here, y is 1. So if I just replace y with 1, instead of y to the 5th, it's 1 to the 5th power. And that just means 1 times 1 times 1 times 1 times 1, which you should know is 1. Remember, 1 to any power is 1, right? Even 1 to the power of 0, 1. Woo! Great. I think I'll end this first lesson right here. Again, I'll write some questions for you guys to solve by yourselves. I'll write the answers at the end. But hopefully you've enjoyed this. If you have, please do subscribe, and there'll be more videos posted if there haven't, or if when you're watching this there isn't already. But if there are, then go and watch those ones. Subscribe, leave any comments, tell me how you guys have enjoyed this. Any tips moving forward, any things that you guys want me to change, or if, hey, keep it as is, we've enjoyed it. I would definitely enjoy hearing that as well. Thank you, and have a good one, y'all.